Okay, this time we're back with page 12 of the running test review. And these are 3 word problems based off of how to calculate total possibilities or total outcomes. In this case, we're dealing with a password that is 4 letters followed by 1 digit. And then the uppercase letters and lowercase letters are allowed and they're considered different. That means that a capital A and a lowercase a count as 2 different things. How many passwords are possible? All right, the thing that you need to look at for these problems, and the question I kind of ask in each one of these cases, is always, is this a fundamental counting principle kind of problem, or is this a permutation/combination kind of problem? So in this case, I would say that because you're not seeing something take like 3 students out of a group of 10 or something like that. So here I don't see that kind of situation. What I see is I'm trying to get a certain letter for my first letter of the password, and then another letter for the second letter, and another one in the third, and so on. So in other words, I have a category for the first letter, I have a category for the second letter, for the third. So I would write that kind of like this. Then I have a letter, another letter, another letter, another letter, and then a number. So how many possibilities are there for the first letter? Well, because you can count capital letters and lowercase, it's like every letter counts twice. So there are 26 letters in the alphabet. In this case, there must be 52 possibilities for the first letter. Hopefully you can see that this is sort of like the license plate problem we did in class. So again, since the letters can repeat, it doesn't say anything about them not being able to repeat. You can assume that each letter has 52 possibilities. And then the number must go from 0 to 10, or 0 to 9. So figure that means 10 numbers. So see, the counting principle says as long as you have separate categories for each thing and you're only choosing one out of each of those categories, then all you have to do is figure out how many possibilities there are in each category and just multiply them together to get the total number of possibilities. This is a really big number, and it should be because it's a pretty complicated password. It requires you to not only use 4 letters and a number, but it also requires you to use capital and lowercase, so there should be a lot of possibilities with this. I'm just typing this on the calculator. And it comes out to 73,116,160 possible passwords, which is good because that means nobody's breaking into that. Okay, so if you look at number 75, I'm hoping that you can recognize the difference between the wording and the style of this problem compared to number 74. This one says, how many ways can a club select a president, vice president, and secretary from a group of 8 people? So that's 3 people that we're picking out of 8. So all it says is, how do you pick out 3 people out of 8? How many possible ways? So this is one of those permutation or combination kind of problems. So you're going to need an n value, and you're going to need an r value. N is the total number of people possible. In this case, it's 8. And r is the number that you are choosing. So in this case, we will be choosing 3 people. So r is 3. All right, the only other question you need to ask yourself then is this a permutation or is it a combination? Because you're choosing a president, a vice president, and a secretary, these are like specific titles. So it's to say if I pick Joe first, Joe is president, then nobody else in the group can be vice president, or excuse me, nobody else in the group can be president. So the idea is that picking somebody first causes the other people to have a different situation. That means that the order is important here. Whereas if I was just picking 3 people to go right on the chalkboard, it doesn't matter what order I want it in. So if like person A, person B, and person C, if I want those 3 people to write on the chalkboard, it doesn't matter if C writes first and then A. That makes no difference. The whole point is that in this case, you're given some kind of title or rank, and that tells you that order is important, which means this is a permutation. So it would be written like this. And the formula for that is to put n over this. Okay. So what we end up with out of this is 8 factorial over 5 factorial. So I'm going to write this out this time so you can see what happens. But at some point you're going to get to the situation where you don't have to write them all out anymore. All the 5, 4, 3, 2, 1 cancels with that one. So all you're left with is 8, 7, 6 multiplied together. Which leaves you with 336 possible ways you could select that. So we're on to Vincent Vega adopting kittens. I'm curious if any of you know who Vincent Vega did it. Anyway. So Vincent Vega is adopting kittens from a litter of 11. How many ways can he choose a group of 3 kittens? So again, you're thinking about, is this the kind where there are multiple categories and I'm picking one thing out of each? Or is this the kind where I'm picking a small number out of a larger number? Well, you can see right here, you're picking 3 kittens out of 11. So this is either a permutation or combination. And now, of course, the question is that an n, again, is the total number, and r is how many we're choosing. So is this a permutation or a combination? Well, let's suppose that those 11 kittens are 11 different colors or something. And if that's the case, let's say that we want a gray cat, a black cat, and a calico cat. Well, does it matter if we take the black cat first, and the gray cat second, and the calico cat third? Or if we change that around and we say the calico, the black, and the gray? Does it make a difference in what order we get the cat? Hopefully, I think you'll say no to that. So in this case, the order does not matter. This is a combination. So this means that we're going to have an 11 factorial on the top, and then a 3 factorial here, and an 11 minus 3 factorial here. So when we simplify it a little, 11 factorial, 3 factorial, 8 factorial. Okay, this means that on the top, I'm going to have 11 times 10 times 9 times 8 times 7 and so on, all the way down to 1. Well, but this 8 factorial right here means 8, 7, 6, 5, all the way down to 1. So that means that on the top, all I'm going to have is the 11, the 10, and the 9. And everything else from 8 down would be canceled by this 8 factorial. However, that 3 factorial is still there. So the 8 is wiped out with all of these numbers that would have been here. But the 3 factorial is not. Remember, you don't cancel things twice. So this is what we end up with out of that. So 11 times 10 is 110, times 9 is 990. And 3 times 2 times 1 is 6. So we need to do 990 divided by 6, which is 165. So in other words, there are 165 ways that you could possibly pick 3 kittens out of this litter of 11. Okay, that's the end of your running test review for now. So your test is Friday.